Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be in chapter 12.5. This is talking about graphing parabolas in standard form. So what is standard form? What does all that mean? We'll also be getting into talking about how we move them from standard form. It's called translating them. And so we'll talk about those things. But let's start off with the idea of standard position. If you look down at the screen, you'll see a little picture. It's kind of a rough graph. And at point 0, 0, you'll see it formed. Well, the parent function, it's called, is the base form of the parabola. It starts at right here, point 0, 0. Okay? And so that's where its vertex is formed. Now, we can have our parabolas in different places. Like you could potentially, your parabola could move all over the place depending on where it needs to go and what it needs to do, depending on what, different things you add to the formula, different things that you subtract to the formula. If you have negative numbers, if you have squareds, different places, it's going to make this thing move around. But in standard form, here's what the equation looks like. The equation looks like y equals x squared. That's it. This is like the base of the quadratic equation. It doesn't have any plus 3x. No. Because when you add that, now we're starting to move things around. This is the pure form. This is the base form. They call it the parent function. Okay, so this is where it all starts right here. Y equals x squared. When you graph it, this is what it looks like because this is the basic setup of that parabola. Now, if you'll turn the page over to page number 470, page 470. You're going to see some words on page 470, and these words are in boldface type at the top of the page. The first thing that it talks about is what's called translational graphing. Translate. What does it mean to translate something? Well, if you're translating in language, it means you're taking it from one language to a different language. If you're translating in math here, you're taking something from one position on the graph to a different position. You're changing its position, okay? You're changing where it is. That's translational. It takes the parent form of the parabola and moves the position or shape of the graph based on changes to the equation. So as we change this equation, our parabola is going to be moving on the graph, okay? The first one on page number 470 is the transformations of vertical reflection. Okay, vertical reflection, what is that? Well, what is reflection? Reflection is when you walk into the bathroom and you look in the mirror and you see yourself in the mirror. It's a reflection. Have you ever noticed that, like, when you look on your shirt, like, you're like, wait, what? It's on the wrong side. It's flipped. It's switched. I can't even read it. Well, that's the reflection of the mirror doing that. You ever gone to a lake and you've seen the trees in the lake and that you can see the trees going up, but then you can also see the trees going down into the lake? That's a reflection. So what is this going to look like? Well, the reflection of this would be to take this parabola from this position and to reflect it and do the exact same thing going down. Okay, so you're just basically taking the parabola and flipping it down. What makes it do that? If you'll look there on table C on page 470, it's a very important table, you will see that if there's a negative x squared, that makes it flip, okay? So what makes your parabola go from the standard position, the parent position, to the reflected position when you have a negative x squared? So where's our parent? Let's go back up to our parent. There's our parent. So how could we flip this one? We could say y equals negative x squared, and that's going to flip it down. That's going to mirror it or reflect it. Okay. The next way is the vertical translation. So that was vertical reflection. This is vertical translation. What does that mean? Well, in vertical translation, here's what happens to it. Let me see if I can do this. I think I can do this. I think this will work. All right, good. So what it does is it moves it up or down. Okay, so it takes my parabola and moves it up. Let's move it down in this case. Okay. So I took my parabola and I moved it out of the parent position. How did I move it out of the parent position? I moved it vertically and I moved it just up and down. I didn't move it left and right. It just moved up and down. Well, what does that one look like? Well, that one looks like y equals x squared plus 3. If we add a constant, actually, let's do this because this is minus 3. We'll call this minus 3. And so this one is a minus 3 because I moved it down. If it was a plus 3, it would have moved it up. Okay? And so that is a vertical translation, moving it up or down 3 spots. You can move it up or down 10 spots or 20 spots. It doesn't matter. All right. And the next one is a horizontal translation. What does horizontal mean? That means left and right. Okay. So now we're moving this thing left and right. How do we do that? Let me select it again. And if I move it left or right, now notice it's not moving off of the X line. I'm not moving it up and down. I'm just moving it along the X line, back and forth. Okay, so let's move it over here, and we'll call that good right there. And so there's our translation horizontally, going left or right. Well, what does this one look like? Well, this one's a little interesting. We're going to learn more about it later, and we're going to learn a whole lot about it in Algebra 2. But this one looks like y equals, or function of x equals, actually would probably be a better way to write it. That's how the book writes it. So function of x, we're not using y anymore right now, equals x squared, but it's not x squared anymore. That's the parent, okay? And so here's the translation. X plus a constant, so we'll say x plus 2 squared. You say, well, where did the x squared go? It's right here, okay? It's right there. And then we have to square this. Well, what does this look like when we actually square it? Well, it looks like x squared plus 4x plus 4 because we have to square that whole thing, or we have to FOIL it. X plus 2, and that's what you would get when you FOIL that. So most of the quadratics that we've been dealing with up until this point, these things right here, they have been shifted left or right. They're not at the standard. They're not at the vertex at 0, 0. So they're moved left or right. So this is more what we've been looking at. This is how that happens as far as the transformation goes. You have to square that. So it needs a number here. This number is actually called, in when we get into it, this is the H number, and the H number is for horizontal. Okay, so it moves horizontal. All right, next is vertical stretch or vertical compression. Now here's what happens with this one. Vertical stretch or vertical compression. Stretch is when it stretches up. It's like a rubber band, okay? You take that rubber band and you stretch it. I like taking rubber bands and like shooting people with it, you know. So you stretch it up in the air and you know, you stretch it on your finger and then you let it go and whew, flies across the room, and then you try to hit somebody with it. But you don't do that. You don't want to be unkind to people. But maybe you try to hit a target or something. You would never shoot people with a rubber band. So don't do that. It's bad. You'll get in trouble. Don't come to me. Okay? I told you not to do it. But vertical stretch. So vertical stretch is when you take it and stretch it up in the air. Vertical compression is when you push it down. Now, let's go down for just a second and read these two things right here. Rigid transformation, the shape of the parabola doesn't change. Let's go back up here. Even though we moved it left and right, the shape of my parabola never moved. Here, even though I moved it up and down, my shape of my parabola never moved. Here, even though I reflected it, the shape of my parabola never changed. My reflection just reflected down, but the parabola stayed the same. Okay? Down here, so those three are what's called rigid. This last one is what's called non-rigid. In non-rigid, it actually is moving and changing. I'm going to draw it using a different color. That's a stretch. We took the parabola and we stretched it up. That green one is stretched. Let me draw one with the pink color, and I'm going to draw one that's compressed. Okay? The pink one is compressed, or it's pushed down. It's like flattened out. Okay? So compressed and stretched. What does this look like? So what does this look like on our equation? Here's what it looks like. It looks like, and it's on your book on page 470, it looks like there is something added to the x. So it's function of x equals, I'm going to write two different ones. Actually, let me write it in the color that I did it in so you'll be able to see it. So the stretch is the function of x equals 3x squared. Notice this number right here. What that does is the bigger the number, the bigger the stretch. So if it was a 2, then the stretch would be smaller than the 3. Okay? And then let me use this pink color to show you what the compression looks like. The compression is if it's a decimal being added, or a fraction, either one, being added to the x squared. So in the compression, when you multiply a fraction to it, it like pushes it down. It compresses it. Why? Because you're multiplying by a fraction, which is making it get smaller. Here, you're multiplying by a number, making it get bigger. So when you multiply by fractions, things get smaller. When you multiply by numbers, by integers, it gets bigger. So that's what's going on there. Okay? Lots of stuff right there. Wow, that was quite a bit of different transformations and things. I have one other thing that I want to show you, and this isn't going to take long, but I want to talk to you about how to graph the parent function. How do we graph at 0, 0? Okay, and that is on page 470 at the bottom. Here's the way that we do this. We just take our point, and we just put it at 0, 0. Now, what you would do with this is you have different values along this line, right? And different values along this line. So now you would take any random value on the y. So let's remember when we did our charts. So this was the x value, this was the y value, and then we just graphed 0, 0. Then I would pick a number on the y, and I would say, okay, I want to know what it is when it's at 2 on the y, for example. Okay, you would take and you would plug in 2 equals x squared. Well, what happens here is when you solve this, you end up getting square root of 2. Actually, let me make it so it's a little bit easier, so you can understand this a little bit easier. Let me make it 4. Okay, 4 will solve out easier. So if we say y equals 4, so we say 4 equals x squared. When we square root both of those, notice that we get a 2 as our answer. 2 equals x. But when we took the square root, we had to say plus minus 2. So over here, we'd put a 2 there, and we'd also put a minus 2. Why do we put the minus 2? What's going on there? Okay. Well, what's going on there is that we have something interesting. We have that it's the mirror. Remember when I told you that this thing looks like the mirror? So when we go over here and we go to positive 2, 1, 2, and we go up 4, 1, 2, 3, 4, we'd put our point. We'd also put a mirror point at negative 2, 1, 2, 1, 2, 3, 4. There's a mirror point over here. Let me erase those marks so you can see it. Notice that when we draw our curve, it looks the same on both sides of the line. That's where the parabola is happening. So what's making the parabola happen? This is what's making it happen, the plus minus, this square. When you solve the other side, that square makes the parabola happen. So how do we do these? The easiest way to do these is just by building yourself a chart. Okay? Plug something in, solve for it, make sure that you do the plus minus, and then you're going to see your parabola start to form there. That's graphing from 0, 0. And then your translations would go from there if you're moving it up, down, left, right, depending on what you've added to it. Okay? Alrighty, well, that's all I have for you for this lesson. Hopefully you learned something there. Hopefully you understand what's going on there with the translations, how it's moving. When we add numbers to it, when we multiply by a number, the graph does different things. The parabola moves around, and that is because we're adding things to it. We're multiplying by things. We're subtracting by things. And when we do that, we're moving the vertex of the parabola to different places. Those are called transformations. Make sure you go back and review those. Those are all on page 370 if you want to look there in your book. Okay? Well, have a good one. We'll see you later. Bye-bye.